So in this numerical, we have the built up C sections, a typical. So it is of 12 mm to 10 mm thickness, and it is also having a one lateral thickness that is of over here, this part. This one is of 10 mm thickness. Okay, so now we have this C section, built up section, which is a composite one. What we have to do is, in return, we have to divide this section into three rectangular forms depending upon the section. So what do I do is, I presume that there is a one and there is a second cut over here. So by this help, what do I do is, I take this as a single member, this as a second single one, and this as the third member. Okay, so we have now one rectangle, let me call it as an R1. We have the second rectangle, let me call it as an R2, and we have a third rectangle, let me call it as an R3. And each rectangle have its own center of gravity. So I call this point, okay, we assume that this is a point where there is a CG1. So I take it as CG1. This is a point where I presume there is a center of gravity. I presume and I take it as a CG2, and this is a point where there is a center of gravity. I consider this as a CG3 for rectangular 3. Okay, so this will be my first step to divide this composite section or built up section into our own known rectangular form. So what we do next step is, the step 1 of any numerical will be writing down the given data. Okay, you can write down as a rectangular 1, this is the area, that means this is the dimension. Rectangular 2, the dimension would be 10 mm into 150 minus 12 minus 10, and rectangular 3, that would be 75 into 10 mm. The next step will be formula. Remember, you have to write down the formula. To calculate x bar, we have the term, this is the thing, a summation of ax by a. To calculate y bar, we have summation of ay by x, a. So the next procedure is, as I told, we'll put a table, we'll write the components. Let us start with the R1, R2 and R3. So R1 rectangular is having, the dimension is 60 into 12. So this is 60 and this is 12. And R2 is having a dimension of 10. This is 10 and the other dimension is 150 minus 12 minus 10, that is equal to 128 mm. Okay, and the last one, rectangular R3, we are talking about this part, which is 75 into 10. So we write 75 and over here 10. So we can write in the component over here as an mm, all component are in mm, area in mm square. This is a distance mm, and this is also distance mm. You can write xi over here, yi for references. So let us start with the first one, R1. So the area is, directly we can write 60 into 12. So the area becomes 720 mm square. Okay, we have written already mm square over here, so no need. So R2 is 128 into 10, that is 1280 mm square. The last one is 75 into 10, that gives you 750 mm square. Now the important parameter that we need to observe over here is the x and yi. If we see, the most mistakes are done in this xi and yi only, because other all simple mathematics, because just area anyone can find it out easy, length into breadth, whatever. The xi and yi is the thing where we do normally mistakes. So to find first x, let us find first xi, the distances. So for this uh, triangle R1, the xi is the distances from this point to this point. Okay, let me take some color for this itself so that you will understand. Okay, this is a distance for the first triangle, sorry, first rectangle. This is for the second one, and this is for the third rectangle, that is 75, 10 and 60. That is a distance. If that is a distance, over here we know that it would be 12 by what is the other distance, 60. That would be 60 by 2, so it is 30, and here it is 128 and 10, and 10 is a distance, so 10 by 2, that is equal to 5, and here it is 75 by 2, pardon me, this auto correction, by 2, that gives me 37.5. Okay, this is the differences that happens. Next is we need to have a yi. What is yi? Now yi is the distances from, for first rectangle, this is the distances from here to here. What is this distance, right? That is yi. How much it is? 150 minus 6, right? 150 minus 6 gives you that distances. Or you can make like this, 10 plus 128 plus this 6, both is same. You can take any one. For this it is, this is a distance, and last for this one, this is the distance. Okay, so let us do that. For first one, the total one, 150 whole 150, this pura whole 150 minus this 6. So for first one it is 150 minus 6, that is 144. You can take any method to calculate. Okay, it is same as a 10 plus 128 plus 12 by 2. it is same. For R2, now coming to R2, this is a distance of 5. So it is 128 by 2 plus 10. So that is 10 plus 128 by 2. That is equal to 74. And the last one is this, and this distance is 10 by 2. 5. So what we do is now a simple mathematical cross multiplication. 720 into 30 for here, 720 into 140 over here. Say 128 into 5 over here, 1280 into 74 over here, 750 into 37.5 over here, 750 into 5 over here. So for the first one, this is a basic mathematics, you just can do by yourself. That is 21600, and this one will be 103680. For this 1280 into 5, that becomes 6400. 1280 into 74, that becomes 94720. Just calculate by yourself once. 750 into 37.5, so that becomes 28125. 750 into 5, that becomes 3750. So what will be our next step would be, here making addition of all or summation of all the areas. Okay, what do? Is we add this all summation, that means the total area. When you add 720 plus 1280 plus 750, that gives you 2750. And summation of AX, that is 21600, 6400, 125, that gives you around 56125. And summation of AY, that is 1036809472 and 3750, that gives you around the value of 202150. What is the last step is? The last step, key important step, is just applying the direct values. So it is 202150 divided by 2750, as well as it is 56125 divided by 2750. So the resultant answer will be 73.5 mm and 20.409 mm. So this is the answer. Okay, this is just a 6 marks question. Generally it used to be a 6 marks question. And one more thing is, just apply it over here, the last. So y bar, that means from x somewhere, that is 73. So 10 and somewhere over here it comes, and over here from here it is 20.4. So if this is 10, 20, 20, so it comes somewhere over here. So what we assumed, or what we get to know the CG from here, or centroid. Okay, let us take centroid. centroid point in the bracket, that is x bar comma y bar. That is how we used to tell the coordinates, right? That is equal to x bar is 20.4 comma 73.5 mm. Okay, so from now we got to know that this distance is 20 and this distance is approximately 73. Okay, so this is what is all about this numericals. So this numerical carries around 8 marks maximum. Okay, 7 to 8 marks. I hope you understood all the concepts and follow up for the other numericals.